if I was looking at your paper, what I will see on your paper is that you have drawn the squares off of each triangle. So, or off of each side of the triangle. And even if the square isn't perfect, in number 2, I should have seen kind of like a square coming off of each of these, even if it's not a perfect square. Okay? And so when I'm looking at these, I should see squares. Okay? So when I look at those squares, I should have seen that A, they told us the information was 5 centimeters. That was our side. Which means the area has to be what? 25. And you want to put centimeters squared. And B, they told us that the length of the side in B was 12 centimeters. Which means the area is 144 centimeters squared. And what we did up above was we added the area of A. So we're taking the area of A, which was 25, plus the area of B, which was 144. And we added those together. And that is our area of C, which was 169. And if the area we talked about was 169, to find the side length, the side of C, C has to be equal to square root of 169, which we know is one of our perfect squares. So 13 centimeters was the answer. Okay? So that's kind of what I'm looking for if we, if we would hand this in. We're not handing it in right now, but you should have the same thing up with that top picture. Okay? I would like you to look at your B2 notes. And our goal throughout this is to think of different ways that we can prove the Pythagorean theorem. And I had someone say, well, I just know the Pythagorean theorem. Great. You're going to have lots of time to apply it. But part of our standard is that you need to be able to prove that it works. So it says, recall a right triangle is a right triangle has a 90-degree angle. The longest side is always opposite the right angle. So when we talk about the longest side, the hypotenuse is always the longest side. Okay? Longest side of our triangle. Okay? Always, always, always. The two other sides are called the legs of our right triangle. And the right angle is often marked with this square. So a lot of times you'll see that, and if they put that marking in there, that really means you just have a right triangle. Okay? So make sure you put the longest side as your hypotenuse. So you write that right under that word hypotenuse. Okay? So as we are looking at your figure, we are now going to be looking at that next part down in your notes. And in that next part of your notes, it says, okay, a right triangle is drawn below with squares on each side. Where is the right angle? The right angle is going to be, so let's draw that in. So the right angle in our picture is going to be right here, right? So we're going to draw that in. That's our right angle, okay? And we could say the right angle is always between what? Between the two legs of our right triangle, right? So it's always between those two legs. So it says, what is the area of each square? So the bottom square is what? 1 centimeter squared, did you say? Right? That's 1. How about this one? Another 1 centimeter squared. And how many are we having here? 2, right? Remember how we divided that up beginning of the last unit? These two together make 1, then we have 2 centimeters squared. And it says, well, how are these areas of these 3 squares related? Meaning, 1, the area of 1, right, plus the area of the second one is equal to 2, the area of the third one, right? Oh. So if this is our A, right, this is our side A, this is our side B, this is our side C. This is the area of triangle A, square A. The area of square B is equal always to the area of square C. It says, how long are the legs? So if this area is 1 centimeter, what's the length of this side? 1 centimeter. The second one is 1 centimeter. Remember, this 2 was the area of that hypotenuse squared, right? Of this squared. That's the area here. So what's the side length going to be? Square root 2 centimeters. We can't find it exactly, right? It's one of our irrational numbers. So our sides were taking the square root of 1, taking the square root of 1, and taking the square root of 2. The square root of 1 equals 1. So it says, how long is the hypotenuse? It is square root 2 centimeters. Could we have put that in our calculator and approximated it? Remember we did that at the beginning of the last unit. Anyone remember 1.4? I think it came out like 1.41. We did that one so many times at the beginning of the last unit, right? All right. So right now on the top of the next page, so you have both pages. So this page and then the page below in your notes, okay? And what you are going to do is you're going to draw some right triangles. Now, in order to get your squares and your triangles so that they don't overlap, it's kind of key to where you draw these triangles on yours. Because as you start doing this, if you try to draw these different legs and with the lengths, it doesn't work too well. So here's my hint. This is what your dot paper looks like on the top. And for this first one, I want you to go in 2 squares, and then we're going to make our leg. It said we have to make the first one said with a leg length of 1 and a leg length of 3. So if we go into this first one, you're going to just go over, in this case, just over 1, and you are going to draw a triangle with a side length of 3. So I'll do it in color here. So this is 3, right? It's not 1, 2, 3 dots. It's 1, 2, 3 units, okay? So draw that for everyone on that page. Kind of check with your shoulder partner. Now we have to go down, right? 1, 2. So do you agree that this has a side length of 3? No. Side equals 3. 1, 2, 3, okay? Not 4, but 3, right? 1, 2, 3. And now over here, we're going to have a side length of 1, right? That's what our side of 1. And someone was like, where are you getting those numbers from? They told us we want a side length of 1 and a side length of 3, okay? To make a right triangle. Can we make a right triangle with the side length of 3 and 1? Yeah. It's going to connect right here, right? I need a right triangle coming off this side. Now, here's kind of the pattern as I'm looking at this. I went up 1 and over 1, 2, 3 dots. So I'm going to go over 1 dot and then go down 1, 2, 3 to right here. I'm going to go down 1, 1, 2. So kind of check with your shoulder partner and see that you're making this pretty close to, remember these have to be right angles. So kind of check with your shoulder partner and help each other as you're drawing that. Okay? Nine centimeters squared. What's our area here? 1 centimeter squared. Oh, remember at the beginning of the last unit when we had to draw to count our area of these squares? Oh, yeah. Okay, we kind of drew those triangles off, right? This has 4 in the middle. So what's the area of this whole square? More than 8.
12, 10.
We have, this is 1, 2, 3, and 1, so it's 3, 6, plus 4. This has an area of
12.
Okay. 10. So if the area is 10, write that on your picture. And you're going to make this one go over to like here. Make it bigger. Okay. If our area is 10, what is the side length of this side right here? Square root of 10. Side equals, thank you, square root 10. So we are filling in, okay? We're going back to that chart and we want to fill in the chart. And the chart said, the leg 1, what was the area? We just said it was 1 centimeter squared. When the side was 3, what was the area? 9. Which, what do we know about the hypotenuse? It has to be What did we get for that hypotenuse side? 10 centimeters squared. I want you to add one column right behind here, and I want you to put side hypotenuse. What would be the side of our hypotenuse? If the area was 10, the side would be square root 10 centimeters. Okay. The next square, you want to make 2 legs of our right triangle with side 2 and 2. My hint for that one is when you're on your dot paper, is you might possibly want to go down here. But you want to make sure that when you're on your dot paper that you kind of have your, right, so that's a side of 2. And then I might put a side of 2 being right here, right? Can I easily find those 2 areas right off, fill in on my up above on that chart? Okay. So I'm filling those in on my chart. Area was 4, right? What's our other area going to be? 4. And now we're making this right triangle. I'm going to go right through that center point, right?
Yep.
And this was a nice one to draw because when you were drawing this, you go out through this point, 1 more. Go down through a point, 1 more. Anyone remember at the beginning of that last unit when we said, okay, these 2 together, like this one and this one, they make how many units? If I slide those 2 up together, how many units do I have? Total of what? These 2 together, we're not leaving for lunch till I get these questions answered. So. These 2 together make what?
1.
Really? I thought 1,
2.
2. So these 2 more are going to make it a, wait, how many squares is this? This is 1. I slide this up. How many total are these? 4. And how many total?
4.
So what is my area of this?
8.
Area equals 8. Side is what?
Square root 8.
Square root 8. We'll go to on our picture, on our dot paper.
Okay.
And my hint is that you want to have your 4, 1 be like 1, 2, 3, 4. So we're going to go this way. 1, 2, 3, 4. And then maybe down 1, 2, 3. And these might overlap, but this is our side of 4, right? And side of 3. And then you're going to still make the right triangle and draw the squares off of each one. So please draw your squares off of each one. Okay. So that each one I should have a square. Right? 1, 2, 3. So I can tell the areas. So here you're going to go kind of down 4 and over that 3. 1, 2, 3, 4. 1. And as close as you can get yours to be as square as possible. Okay? As close as you can get yours to be as square as possible. And as you finish drawing yours and you put your areas in each one, then I want you to fill in the chart. And we want to kind of try and look at if there is a pattern in our chart that we are seeing. So, here's the area, 9 centimeters squared. Wally, when the side was 4, the area was 16 centimeters squared. And if I look up above, what do I know about the area of like 1 plus the area of like 2? It's always equal to. So if I was looking at this, I could kind of think of, oh, if I take 1 plus 9, it is always equal to the area of our hypotenuse, right? Mm-hmm. 8 plus 8, or 4 plus 4 equals the 8. So this one should be 9 plus 16 equals, should be 25 centimeters squared. which means what's the side length?
5.
5, because you're taking square root
Yeah.
of 25. And I had some people when they were looking at the squares, I don't see how you got 25 for here. And if you look at this, this is like a 3 by 4, right? So that's 6 in that triangle, and to here is another 6, so these two together is 12. You could have broken it down other ways if you were looking at this one. This is another one, so when we're looking at our pictures here, we could have this one, which is another 6 by, these two together is going to give us another 12 plus the 1 to get 25, okay? So as you're looking at those in different ways. So we want to continue with that pattern that we just kind of looked at here, meaning if you take the area of the leg plus the area of the leg 2, it will always equal to the area of the hypotenuse, okay? So as we are doing that, it says, as you look at this picture, does the Pythagorean theorem work for a non-right triangle? So let's try our theory. Off the bottom, that's the easiest square to draw, right? It's 1, 2, 3, 4, 5, so you need to go down 5, right? And we can tell what that area is right away. If it's 5 by 5 is 25. So this has an area of 25. And we're thinking this is kind of the hypotenuse. It's the longest side, right? So the side was 5. The easiest way to count the side is just look at the 5 dots. But these two sides aren't as easy to count, so we need to draw the squares, right? So draw the square off of this one. That means I'm going, if I'm looking at this one, it was 2, 1, I'm going up to this point right here. I'm going to go to this point. Please draw that square and think about what the area is. And in this one, we are going over, and I think the 1 goes off, right? Does it kind of go, like it should be like right here, right? This one should be like here too, right? In order for it to be exactly square. You might go to that top dot. Let's see. I think it goes to the top one on each one. It goes to here. Right? Is that where you had that? Okay. So if I'm looking at it, what was the area of that smallest square right here? This has an area of, no, it's not 2.
3.
Think of these triangles maybe going off to help you.
4.
3.
So 1 in the center, right?
5.
It's an area of 5. Area equals 5. How do we get 5? I have 1 in the middle. These two together make 2. These two together make another 2. 2 plus 2 plus 1 gives me an area of 5. In this one over here, if I'm looking at, I have 4 in the middle, right? So my total area is way more than 4. These two together make 3. These two together make another 3. Area is 10. So the question is, does it work if our theory? And in this case, no. Why not? It only works for right triangles. Because is there any way that 5 plus 10 will ever equal 25?
No.
Right? This is the area of the small one. Area of 5 plus area of 10 equal area of 25, never. Okay? Small area plus small area equals large area, not if it's not a right triangle. It only works when we have right triangles. So as we're looking at this, we're going to write in this next part. We are almost done with our notes for today. We're really close. So it says, what is the pattern for the Pythagorean theorem? The pattern for the Pythagorean theorem that we want to write down is, it has to be a right triangle. So it must be a right triangle in order for the Pythagorean theorem to work. Must be a right triangle. Please write that first. And then it is the sum. Sum means to do what operation? Add. So I'm going to put a plus right behind the word sum for some of you so you remember. The sum of what? Of the area of the sum of the areas of the legs That means you're adding the small area, right, plus the small area. The sum of the areas of the legs is equal to the area of the square, on the hypotenuse. So we are not always going to draw these triangles with the squares off of them, but this is to kind of look at that. And it says, suppose that the right triangle has legs of A and B. Does it matter which order where A or B are? No, a lot of times they have A being the smaller of the two, but it doesn't matter. And the hypotenuse is C. We don't actually use actual measurements from those sides, but we can write a rule or a formula. So this is what I want you to write down. We are taking the side length, right? Side length A, and we are squaring it. That's how we find the area, right? Whatever the side is, we square it. Plus, we're taking the side length of what? B, and we're squaring it again. And it is equal to the side of our hypotenuse, which is really C, right? Squared. And this is what the Pythagorean theorem looks like. It looks like A squared plus B squared equals C squared. Tomorrow we're going to get into another way of proving this. This is called our Pythagorean theorem. Tomorrow we talk about Pythagoras a little more. So this is called the Pythagorean, please write this down, theorem. And the only thing different about a theorem in mathematics is simply another name for a math rule. So it is just another name for a mathematical rule. Anytime you see the word theorem, it has actually been proven that it works and that it stays as we are looking at that. So if you would now turn in your workbook. We have a little square drawing on question 4 and 5. But please take a look at number 1 as we start off. So looking at 1, 2, and 3 in your workbook. So when you look at number 1, it says the right triangle has lengths 5 and 12. Draw and sketch a triangle. Find the areas of the square. So it's kind of like what we did today. So you want to draw, it doesn't have to be exact, right? But you want to say, oh, this is 5, right? And maybe this is 12. And make a right triangle. And then it says, draw and sketch a right triangle. Find the area of the square drawn on the hypotenuse. So if this is our side, right? Side of 5 and side of 12. How are we finding that side? We are taking the 12 squared, the side squared, plus the other side squared, right?
Yes.
Is going to be equal to the side C squared. So you're going to get this answer, but it doesn't say what is C squared. So when you add these two numbers together, 144, right, plus the 25, that is the area, right, of C. You want to find the side of C, okay, so keep that in mind. So it just says, this first one says find the area. That's part A. Part B is find the side. Okay, so this is the area up here. Then you use that to find this next one, okay? Here it says use the Pythagorean theorem. So for the rest of the questions, when you're doing 3 and 4, I want you to start with the theorem. I need on your paper, A squared plus B squared equals C squared. Someone said, do I have to write that every time? Yes. Go around your picture and identify your A and B, because I was amazed at how many people had to take 3 or 4 points off on their test because they had the wrong formula. And if you had the wrong formula on all those ones with volume, which there was a bunch of people that had the wrong formula, totally didn't write the formula, didn't have the right formula, totally everything was wrong, right? Like I hardly had a chance to give you 1 point on that whole part out of 16 points because people started with the wrong formulas. So when you do these, yes, I need the formula on your paper because some of you that still didn't get into your brains, unfortunately. Around the picture, identify your A and B. Does it matter if 6 is A or B?
No.
Sit up, please. Doesn't matter. Usually we go the shorter side is A, and then the next side is B, but it doesn't matter if you want to call this one A and B. And then you're going to show me your work. 3 squared plus 6 squared. You're going to keep this as C squared. You guys know what 3 squared is. 3 squared is? No calculators needed. And 6 squared is? 36. Add those two together. So we should have 45 is equal to C squared. Now, in our last unit, we said, okay, that's the area of this side. What is C equal to? So we're going to say C equals the what? Inverse of squaring is to find the square root of 45. This is our exact answer, the square root of 45. It says use the Pythagorean. So this is the steps I need you to show. You're going to show me the formula. You're going to show me the numbers in the formula. You're going to show me what C squared equals, and then you'll go to what C equals. I think it's helpful to put this step in the middle, but some people won't. If it asks you to, I can't remember, you can check in the back if it asks you to find the approximate length or the exact length. I want you to look at number 4, please, right now in your workbook. So you're going to do number 3 very similarly. Please take a look at number 4. And what I want you to think of is what 2 perfect squares add to 17. So think of your list. What 2 perfect squares add to 16? Add to 17. 2 perfect squares. So think of your list of squares. 1, 4, 9, 16, 25, 36. Which 2 perfects add to equal 17? 1, 4, 9, 16, 25, 36. Obviously it can't be 25, right? Because it's too big. So 16 and what?
1.
16 and 1. What does that mean? So if the areas, right? So if I have 1 plus 16, I know equals 17. It says we want the side length to be 17 units. Find 2 points, okay? When you look at question number 4, right? Is that all we have to do? Yeah. This is no, I got the one. Let's see. First page was right, right?
Yep.
All right, so then the second page of B2, I have the wrong page up there. You're going to finish through that second page with finding those areas like we did. Okay, so mine's off. This is B3. I was very confused. So don't worry about this for today. That's going to be tomorrow.